Hello students, today we are going to start the third lecture on current electricity. Let's start today's lecture. First of all, we will see the function of a battery. So battery basically does, it converts the chemical energy to electrical energy. Battery converts chemical energy to electrical energy. And it maintains a constant potential difference across conductors. It maintains a constant potential difference across conductors. If you remember, when we are discussing the drift velocity, there I told instead of putting an external electric field and joining the conducting wire to the both end of the conductor, you put a battery there to maintain a constant potential difference and join both end of the conductor, right? Then we will see what a cell is. Basically, you take a group of cell and connect in appropriate way, you will end up with a battery. Basically, cell, you can say that battery is a group of cell. You connect in appropriate way many cells, you will get a battery. So this is your cell and this is a negative terminal and this is your positive terminal of the cell, you can say, or symbolically it is denoted like this is positive and this is negative, right? If I take this side, this is your one side is your, this side is positive terminal and this side is your negative terminal of the cell. Similarly, if you see a battery, it is positive side and it is negative side, or you can say that this is the positive terminal of the battery and this is negative terminal of the battery. Okay. Now we'll see how it is converting chemical energy to electrical energy, right? Very briefly we will discuss here. So to do this thing, let's take a container, do the experimental setup. So this is a container, right? So inside the container there are electrolyte solutions are there. You know what electrolyte solution is? Electrolyte solution is the solution where the ions are present, positive ions and negative ions are present. So this is your electrolyte solution, right? And in this electrolyte solution you dip two metallic plates. This is one metallic plate and this is another metallic plate, right? There is two metallic plates you put in this electrolyte solution, and you remember these two metallic plates has to be different metallic nature. That means if this is copper, this can be gold or this can be aluminum or something else. This cannot be, if this is copper, this cannot be copper, right? This is the experimental setup. So as soon as you dip this two metallic plate in the electrolyte solution, what will happen? Whatever the positive ion and the negative ion inside the electrolyte, they will move with some unknown force, with the help of some unknown force. Let's say that unknown force I am giving F. The positive ion will move and deposit here with this force. So it will be deposited here, right? And the negative ion move with this unknown force, with the help of unknown force, and deposit here, right? Then you will see here the positive ions are deposited here and the negative ions are deposited here. That means there will be a electric field from this to positive to negative plate. There will be a electric field here, right? And now this electric field is opposing the motion of positive and negative ion, because if this is the electric field, the force on the positive ion will be along this direction. That is your electric force. For this negative charge or negative ion, this will be negative force. Clear? Along this direction. So the time will come when the force due to this electric field on these ions will be same as this unknown force, then there will be no motion of these ions, right? This side will be positively charged and this side will be negatively charged now. Now what I do, I take a conducting wire and put it here. Connect these two metallic plates. Basically what will happen now? In this metallic plate, the negative charges are there. Negative ions are sitting here. So that electron will move, or the negative ions I can say, it will be move along this direction and come to this positive plate. And this negative ion and positive, when it will come to the positive plate, it will neutralize, positive and negative get neutralized, and there will be a less negative charge on this plate. So now if there will be a decrease in charge and here also decrease in charge due to neutralization of the positive charge due to the negative charge, what will happen that this force due to electric field will decrease, because there will be decrease in electric field, because here the charge also decrease, here also charge is decrease, the electric field is decreasing now, that's why. Then there the unknown force will be more than the electric force. Then one electron will move here and sit here, the positive ion will be coming here and sitting here. Again one electron will flow, and this process will keep going on until all the ions inside the electrolyte solution will finish, right? Then you tell that your battery get expire or battery is not working now, right? So whenever this all ions will be finished inside the electrolyte solution, you will tell that your battery is expired, or you can say that there will be the battery is not functioning, the battery is not working. Okay. Now if the electron is moving along this direction, you can say that the current will be along this direction. So there will be a current flow through this resistor. You can put, resistor means you can put a bulb here or anything you can put here, a fan or something you put, and you will see that if you put a bulb it will glow because the current is flowing here, right? Okay. Now if you look at inside this electrolyte solution, this positive charge is moving along this direction, negative charge is moving along this direction. That means there is a current inside the electrolyte along this direction. There will be a current inside the electrolyte along this direction, because the positive ion is moving along this direction and negative ion is moving along this direction. You know that current direction is same as the direction of positive charge or positive ion. Clear? So inside the electrolyte, if there is a current is flowing, that means you will tell that there is some resistance inside the electrolyte, and that resistance I called as internal resistance. That resistance I called internal resistance, and that is small r, right? This is called internal resistance. This resistance is inside this cell or inside this, if you take many cells inside this battery or inside this cell, the resistance is inside this cell, right? This resistance is due to the cell or inside the cell. Okay. Second thing, what we got? We got that this unknown force is doing some work to move this negatively ion or positively charged ion, right? Positive ion or negative ion. So there we defined an EMF. So what is an EMF? EMF we'll see in detail. This is called electromotive force, but it is not a force. Here I am just defining this one, we'll see in detail. So what it is saying that the work done by battery to move charge Q divided by Q charge. How much work done the battery is doing, that means this unknown force is doing to move this charge divided by the charge. This is called your EMF. We'll see the definition of EMF again and again in 2-3 ways, but this is one definition of the EMF. Work done by the battery to move a charge per unit charge, this is called your EMF. And who is doing work here? The battery is doing work here. By which force? This unknown force, right? That force we don't know. This with the unknown force it is doing the work, and the charge is getting deposited, then the electron is flowing, then the current will be opposite the motion of the electron, then will the, if you put a bulb there, it will glow up, right? This thing is going to happen. Okay, two things we got. One is internal resistance, small r, and EMF, right? Okay, hope you understand this one. Let's go to this. Now we'll see that EMF in detail, what it is saying. EMF is defined as energy supplied by the battery or cell or work done by the battery to flow the charge in a circuit per unit charge. Same thing it is saying. So EMF basically, if I write, is equal to what? Work done by the battery to move a charge per unit charge, work done divided by Q. Work done by, this is work done by battery, right? So if I ask you what should be the unit here, you will say that this will be work done, you can write joule per coulomb. The unit will be joule per coulomb. You see here, the name is electromotive force, but it's not a force. So this is not a force. So we can say that this is not a force, right? EMF is defined as work done by the battery to flow a charge in a circuit per unit charge. Can you write down the dimension for it? You will say that dimension of the work done is M1 L2 T minus 2, and this will be coulomb, can be written as I into T, right? So you can find out that this will be your obviously M1 L2 T minus 3 I minus 1, right? And if you remember joule per coulomb in electrostatic we have studied, this is also volt. If you remember, joule per coulomb is your unit is volt. So EMF unit is volt also, right? Okay. Now I'll see how to represent a cell. We'll see the cell, the function of the cell, right? How it is happening. There is a resistance and internal resistance inside the cell from the electrolyte solution, and there is also EMF. How we will represent? To representation of cell, let's take a ideal cell. So let's take a first of ideal cell. So ideal cell is basically the internal resistance is 0. Then you will show that this is your positive end. I can take this is A, this is your B. This terminal name I am just giving, and this is your cell, and this has EMF E, right? EMF E. EMF basically denoted like this E. So you can write here E equal to also EMF, right? This is E. Now if you take a real cell or practical, cell, right? So what will happen here? Or real cell, so this terminal is A, and this is your positive terminal, negative terminal, and this is your internal resistance R. This has a internal resistance of R, and this is EMF E and this is B, right? So A is your basically positive terminal, B is your negative terminal. So A is your basically positive terminal of the cell, B is your negative terminal of cell, right? And in practical cell there will be a internal resistance will be there, but in ideal cell there is no internal resistance. Clear? This is how you represent a cell. Okay. Now I want to tell you two important things that you have to remember, and this thing we are going to use again and again throughout the current electricity chapter. So it's a very important concept, you have to remember this thing. So first remember the Ohm's law. Let's say I am taking this resistance, right, R, and this side is, let's say, VA, and this side is your VB, potential I am writing. So if you write Ohm's law, you can say that VA minus VB equal to I into R. Here VA is greater than VB. Basically VA is higher potential, VB at lower potential. So you can write this one. I want to write down this one in another way. So just see here. So I am taking, this is a VA and this is the resistance and this is B. This is your VB and this resistance is R. Okay. And the current obviously flowing from along this direction. Here the current also flowing along this, because this is higher potential, this is lower potential. So what I am telling that whenever you are going in the direction of the current through the resistor, there will be a loss in potential. And how much it will loss? I into R. You listen this thing carefully. There will be a loss in potential. How much potential it will lose? I into R. So I will write minus IR. If I am moving along the direction of the current through the resistor, if I am moving like this through the resistor, I have to write minus IR. Then I want to write down this. So obviously here the potential is VA and here the potential is VA, here also potential is VA. As soon as you cross this resistor, there will be a potential drop of IR. So you will write minus IR. So you will write minus I into R. And you reach here, here the potential will be VA minus IR. This is VA and you jump through the resistor, this will be VA minus IR. Now this potential VB equal to VA minus IR. Because here the potential is VB and here the potential also VA minus IR. If you see here, I can write VA minus VB equal to IR. Clear? See here, it's satisfying this Ohm's law, right? So I can write, you just remember whenever I am going along the direction of the current through the resistor, there will be a potential drop of IR. So VA minus VB equal to IR. Clear? One more thing. If I will move opposite direction of the current through the resistor, there will be a add in potential, or you can say that increase in potential of IR. So let's say I am moving from here to here, opposite the direction of current. The current is moving along this direction, right? The current is moving along this direction. But if I am moving from opposite direction of the current through the resistance, then there will be a potential increase. That potential increase plus IR. So how I will write again? So you will tell that VB, you come here, this is VB, this potential is VB, here potential VB, here also potential VB. As soon as you cross the resistor, there will be an increase in potential VB plus IR. So I can write here the potential. If I write here, the potential will be VB plus IR is equal to whatever potential here, the same potential here, this will be V into A. Correct? So I can write VA minus VB equal to IR. See, again it is satisfying the Ohm's law. So two things you have to remember. Whenever you are moving along the direction of the current through the resistor, there will be a potential drop of IR. That means minus IR you have to write. If you are moving opposite direction of the current through the resistor, there will be an increase in potential, that is I into R. Clear? So you can write like this. Now come for the cell. So if I take a cell, this is positive and this is negative. Let's say the EMF is E, this is VA, this is your VB. Right? Whenever you are going from positive terminal to the negative terminal, or you can say that positive side to negative side, there will be a potential drop of E. So here you can say that if you are moving like this, there will be a potential drop of E. That means I will write minus E. If I want to write down how I will write, you will say that this is VA and this is also VA, this is also VA, this is also VA. As soon as you cross, you drop a potential, that is minus E is equal to your VB. So VA minus VB is your E. You can write. Now if you are moving in this direction, so you will say that whenever you are moving from negative to positive, there will be a increase in potential, that is plus E. So if I write down the equation now, you will say that here the potential is VB. You come here, this is potential is VB, this potential is VB. You jump the cell, you gain some potential plus E equal to VB. Here the potential is VA. Here it is VA. So you jump here, you will see that the potential will increase by E. Right? The potential will increase by E. So here the potential VB plus E, here it is VB plus E, it is equal to VA. So if I want to write down VA minus VB is equal to how much? Your E. This way you can write. Clear? Now I put, let's say I put a resistor. Right? This thing is clear now. Now what I will do, I put a resistor here. Let's say this is your VA and this is your cell and there is a resistor here. Or you can say this is a cell which has internal resistance R, you can put this is small r. And this is your VB. And the current is flowing basically in this direction. Can you write down the equation like this? You will say yes sir, I can write. So this is VA. So this is your VA. Now you are moving from positive to negative. So this is EMF E. If I write this EMF is E. Yes. So if you are moving from positive to negative, there will be a potential drop, that is minus E. That thing we have seen here, minus E. So you will write minus E. Clear? And so the current is flowing in the opposite direction you are moving, right? So you are moving along this direction, the current is flowing along this direction. Which condition it will be? This condition. VB plus IR equal to VA, right? So you are basically, you are coming from this side and the current is flowing along this direction. So you are coming from this side, the current is flowing along this direction. So VA minus E you can write here, it will be a, if you come here to here, there will be a potential increase, that is IR, because if you are moving in the opposite direction of the current through the resistance, it will be increase in potential. So this will be plus I into R. Small r we have taken, na? So you can take small r here. This will be small r. So I into small r, right, is equal to your VB. Clear? So I can write VA minus VB. So VA minus VB is equal to E minus IR. This is going to happen. Clear? Okay. Now one more thing, one more problem we will do here. Let's take this case. Same arrangement I am talking about. This side VA. This is the EMF of the cell, and this is the internal resistance of the cell. This side VB. This is internal resistance of the. Now here previously the current is flowing along this direction. Now I am saying that the current is flowing in opposite direction here. The current is flowing like this. I current is. Can you write down the equation here? So what you will tell? You will say that if I am moving along this direction, I will write VA, then I am jumping through this cell. So this is positive and this is negative. So whenever I will jump, this will be minus E. Minus E potential will be dropped. So VA minus E. Then I am moving along the direction of the current through the resistor. So there will be a potential drop. How much potential drop it will be? Minus IR. Smaller way. So minus IR. Clear? So E minus IR is equal to VB, because you reach here, here the potential is VA minus E minus IR, that is equal to your VB. So here I can write VA minus VB equal to E plus IR. Right? This is your relation. Correct? We did for everything here. So depending on this situation, you can write down this type of equation, right? The two things you have to remember. First of all, for the resistor, and second for the cell. For the resistor, if you are moving along the direction of the current through the resistor, then there will be a potential drop of IR. So that you will write minus IR, because potential is drop here. If you are moving opposite direction of the current through the resistor, there will be increase in potential, that is plus IR. Clear? For the cell, you will tell that if you are moving from positive to negative, this is positive and this is negative, there will be drop in potential, that will be minus E. If you are going from negative to positive, there will be increase in potential, that is plus E. That thing you have write and you can solve like this. Okay. Okay. Now let's do some problem. So this problem now we can do easily. So they are asking VA minus VB. So it will be easy for you to find out, right? VA minus VB here. So you will say that this is VA. So I am doing here. So you will tell this is VA. 2 ampere is current is going. So I am just drawing here again. So this is your VA. This is 2 ohm resistor, and there is a battery they have connected or cell they have connected. This is B. So they given E equal to 10 volt. This is VB here. They are asking VA minus VB, you have to find out. You know everything. The current is flowing along this direction, 2 ampere. So you will tell that along the direction of the current, if you are moving through the resistor, there will be a potential drop. So you will say that VA minus of 2 into 2. Because why it is minus? Because you are moving along the direction of the current through the resistor, right? And here what is happening? You are moving positive to negative. So what will happen? There will be a negative, or there will be a drop in potential. That means you can write minus 10 volt. So VA, here I can write here. So here it will be VA minus of 2 into 2, right? Minus of IR. So this will be minus of 2 into 2 minus of 10, because it's positive to negative, is equal to your VB. So VA minus VB equal to your 14 volt, right? This should be 4 plus 10 will be 14 volt. So answer will be your 14 volt. Clear? Now see this question. So this is A, VA, this is 2 ampere, this is 2 ohm, 3 volt, 1 ampere, and this is VB. So let's say I am drawing here, as you can see here. So this is your VA, this is 2 ohm resistor, and here it is 3 volt and 1 ohm resistor, and this terminal is your VB, terminal B, and this is how much current is flowing this direction. This is I equal to 2 ampere current is flowing. They are asking VA minus VB. It's very easy, right? So you can find out now. So what you will do? So you will tell that this is VA minus, why minus? Because you are moving along the direction of the current through the resistor. This will be minus 2 into 2. You are moving from positive to negative. You are moving from positive to negative. So there will be a drop in potential, minus 3. And here also the current is how much? Current is also 2 ampere, right? So everywhere it is 2 ampere. So this is 1 ohm. You are moving along the direction of the current. So it will be, potential drop will be minus 2. Or potential drop will be 2. So you will write minus 2 equal to your VB. Clear? So you can write VA minus VB is coming as, this will be 4 plus 3 7 plus 2 9. So this will be 9 volt. Clear? So this will be plus 9 volt, because they have given plus minus, right? So it will be, your option number 4 will be correct, right? So your answer will be plus 9 volt. Okay. Now do this question. What they are saying? A student measures the terminal potential difference V of a cell of EMF E and internal resistance R. So you know that how to represent a cell. This side, let's say VA, and this is your EMF, and there is a internal resistance to the cell, that is smaller, right? This full is a battery, and this side it is VB. Now read. A student measure the terminal potential difference V of a cell. So these two are terminals we talk about. So terminal potential difference, so they given V. V minus, that means VA minus VB. This is the terminal potential difference, right? And EMF E they have given, internal resistance small r they have given. As a function of the current I flowing through it. So I current it is flowing through it. Let's say I current it is flowing, right? Or you can say any direction here. Let's take any, this direction it is, current is flowing, right? You can take. Okay. The slope and intercept of the graph between V and I. Okay. The current is flowing along this direction, right? And this is EMF, this is R, you have to find out here. So you can write down the equation. So what you will write down? So you will say that VA, I am directly writing minus E. You are moving opposite direction of the current through the resistor. So this will be plus IR equal to your VB. So VA minus VB is equal to E minus IR. So V equal to E minus IR. This equation you got, because VA minus VB equal to this thing. So the graph they are doing that as a function of I and fluid, the slope and intercept graph between V and I. So draw the graph. This is V, this is your I. This equation you see here. When current is 0, V equal to E. So V equal to E. Right? So that means the y-intercept is what? The y-intercept is your y. So y-intercept is equal to your E, because it's intercept here. Now whenever the E is 0, the V equal to minus IR, right? So if I put V equal to 0, you will tell that I equal to how much? E by R. So here it will be V equal to 0, I equal to E by R. So connect here, right? And what is the slope here? You will say the slope will be minus R. This is like same equation, right? If you vividly see y equal to mx plus c, right? C is basically what? C is your E and I is your x. This I is your x. Y is your V and M is your what? M equal to your minus R. So the slope here equal to minus R, right? Now check here. So they are telling that then the respectively y, right? Intercept they are asking, right? So intercept will be y-intercept is your y E and the x-intercept is your E by R and slope is minus R. So first of there this is the slope. What is the slope here? Slope will be minus R. So which option is there? This is minus R and this option will be correct, right? And then respectively y coordinate, y-intercept is your E. This is clear, right? Okay, this is done. Now we'll see electrical power. So electrical power basically defined as the rate at which electrical energy is created or consumed by the electrical device. So the rate at which electrical energy is created or consumed by the electrical device is known as electrical power, right? Or electric power. So if I write electrical power is P, so this will be U by T. Energy consumed, or this is called your energy created per unit time, right? So this will be, you know that this will be joule per second and this can be written as watt, right? So the unit will be watt. Okay. If you write down the dimension for it, so you will tell that this will be energy will be M1 L2 T minus 2 divided by second will be T. So the dimension formula for it M1 L2 T minus 3. Clear? This is the case. This is the dimensional formula for the power, and unit obviously what, you know this thing, right? Now we'll see the concept of source and load. First we'll see the source. Source is the electrical device, or you can say that any electrical component which is basically creating the electrical energy, right? Which is basically creating the electrical energy. Okay. So this is, let's say this is a source, right? How it is creating electrical energy, we will see. This is a source. In this source, the current is flowing along this direction. How it is generate the energy, you just imagine. Let's say dq amount of charge is flowing through this source. I am taking this one is lower potential, this is potential is 0, and this side potential is V. This side potential is 0, you can say just put this side potential is 0. This side potential is 0, and this side potential is your V. What I am taking that this side potential is your 0, this side potential is your V, and this is a source. If the current is flowing along this direction, that means the dq charge also flowing, the positive charge also flowing. What will be the energy here? Ui, that is 0, because dq into potential will be your potential energy. Here what will be the potential energy? U final will be your dq into V, right? So see here, the dq amount of charge is gaining some energy. That's what the source is doing. It's created the electric energy, right? It coming from, the current is flowing from lower potential to higher potential. Initially the energy is 0, final it is energy equal to dq into V. So can you tell me that how much energy is created? Energy is created, dq into V energy is created. The rate of energy created will be how much? So you will say that that is equal to power, and power can be written as rate of energy created, dq into V divided by dt. So this will be V into I. So you just remember that power can be written as V into I, the potential difference into the current, how much current is flowing, right? Power equal to V into I. Okay. And one more thing, for the source, you remember here, for the source, or the current, for the source, the current flow from lower potential to higher potential, lower potential to higher potential, right? For a source, the current will flow from lower potential to higher potential. You see here, that's how the energy is created here, right? And source is creating the energy. Now we'll see for the load. What will happen for the load? So basically in load, let's take this is a load, right? In the load, it will consume the electrical energy. So if you'll say that if the current is flowing along this direction and the dq charge is flowing along this direction, and this side will be your higher potential and this side will be your lower potential. So you'll say that initial energy will be V into dq. Final energy will be 0. That means the charge is lose some energy. How much energy it lose? V dq amount of energy it lose, right? And this load consume this electrical energy and give, let's say you put bulb here, it will give you light energy. If you put a fan, it will give you air, right? So similarly you can say that this load is basically consuming that electrical energy and giving you some light energy, sometimes heat energy, like that it is giving, right? Okay. So now can you tell me how much energy is consumed? Energy is consumed is equal to V dq, amount of energy is consumed. Clear? Now power can be written as energy consumed per unit time or rate of energy consumed. So power can be written as V dq divided by dt. So this will be V dq by dt or I. So you just have to remember power is written as V into I, potential difference into I, the current flowing through it. And this formula is everywhere applicable. Power is equal to V into I. You have to remember this thing. Clear? And in load, one thing you observe, the current is entering at higher potential and leaving at lower potential, right? So I can say that current flow from higher potential to lower potential, right? The current will flow from higher potential to lower potential. Clear? For a source, the current will flow from lower potential to higher potential. That's how the charge is gaining some energy, because it's creating the electrical energy. For a load, it will consume the electrical energy, so the current will flow from higher potential to lower potential. Clear? Now we'll see the electrical power consumed by the resistor. So this is point A, which has the potential VA, and this is the resistor having resistance R. This is point B, this has potential VB, right? The current is flowing inside the resistor, I current, let's say, flowing. That means the VA is greater than VB, obviously. Again I am repeating, VA is greater than VB. Current will flow from higher potential to lower potential. This resistance or resistor is basically behave as a load. This is basically behave as a load. Because whenever you put a resistance, you know that there will be heat generated, right? So it will consume the electrical energy. So it will behave as a load. That's why we always tell the current will flow from higher potential to lower potential. See the load, the current will flow from higher potential to lower potential. You got it, right? Why we are talking about the resistor and the current is flowing from the higher potential to lower potential. This is clear, right? This is your load. Now tell me, power can be written as P equal to V into I. What is V here basically? V can be written as VA minus VB. Clear? This will be your VI. And this power also can be written as VI can be written as V also can be written as V equal to IR I can write. So this can be written IR into I. This will be I square into R. So power equal to I square into R. Power equal to V into I. What else I can write? P equal to VI. So I can be written as V by R. So V into V by R. So this will be V square by R. So power also V square by R. Clear? So I can write the power consumed by the resistor in this format: P equal to VI, P equal to I square R, P equal to V square by R. And we will see where we will use this formula, right? This formula will be applicable for some circuit, this formula will be applicable for the some other circuit. So basically it is not like that this formula will be applicable only. So you can put any formula and you will get the answer, but if you apply this formula for some circuit, the answer you are getting very easily, and if you apply for this formula for some other circuit, you will get the answer very easily, right? So all this formula you have to remember, and we can use this formula in different circuit, right? Depending on the circuit, we will use this formula, right? Let's take one example. Let's say this is your 10 volt and the resistance is your 2 ohm, and here this is 2 volt. Obviously you know the current will be how much here? Current will be 10 minus 2, or you can calculate here and directly write, right? So I will be how much? I will be 10 minus 2 divided by 2, that is 8 by 2, that will be 4 ampere. This will be 4 ampere, right? So this will be 4 ampere current is flowing. Now I am asking power consumed by the resistor. So you will know that P equal to basically V into I. So what you will tell, V equal to how much? 10 minus 2 into I is your 4. So it will be 8 into 4, that is 32 watt, right? You know another formula, you will say that I won't use this formula, I will use P equal to I square into R. So I will how much? 4 square into R will be 2, this will be 16 into 2 will be 32 watt. You will say that I want to use this one, I will use V square by R. So use V square by R. So V is how much? 10 minus 2, 8. This will be 8 square divided by resistance is your 2 ohm. So this will be 64 divided by 2 is 32 watt. So in each formula you will get the same answer, right? This thing is clear now. Okay. Okay. Now we will see the power output of a cell or battery. So basically how you represent a cell. So you will say that this is your VA potential and there will be EMF, that will be E, and there will be internal resistance of the cell. This is your VB. So basically we are taking an practical cell, or you can say that this is a real cell, right? Where the internal resistance is present. Okay. So power can be written as, how you write power? So you know that power of this cell. This is full is one cell, right? So inside the cell there will be internal resistance and there will be a EMF. So this is full cell. So power can be written as V into I, right? So V you can write VA minus VB, right? VA minus VB. This will be VA minus VB into I. Clear? Now first condition I am taking. I am taking the current along this direction. I am taking the current along this direction. I is along this direction. Now tell me what will be the power. So you will say that power equal to V into I, VA minus VB into I. Can you find out the current in this situation? You will say yes, I can find out the current. How will you find out the current? So you will say that this is VA. This is VA. You move along this direction, you are jumping through this EMF, this will be minus E, and you are moving through the resistor opposite the direction of current, this will be plus IR is equal to your VB. So VA minus VB is equal to E minus IR. So current will be how much now? I will be how much? So you will say that you can find out the current will be VA minus VB, that I am writing V, that thing I am writing V. So VA minus VB, this will be your V. So VA minus I current will be V, or you can put here V equal to E minus IR. This thing you got. Correct. So current you can get here E minus V divided by R. This will be your current. So can I write here? This will be your power, can be written as VA minus VB is what? V. This will be E minus V divided by R. This is your answer for this thing. Power will be this much. Or what I can write, you know that V square bar I also you know it, right? Or you can put this V value here. So if you write down the V value here, this power will be, can be written as, I am just try to write in different format so that it will be easy for you. So VA minus VB is V into I. So I am just replacing this V from this equation. V equal to E minus IR. So if you write E minus IR into that current I. So this will be your EI minus I square R. Clear? This will be power output by the battery. Clear? This will be power output by battery, or this one also power output battery, but there is different type of formula you can write. So from this formula, what we can get here, you just see. EI is the power output by the cell. EI is the power output by the cell, because power equal to V into I, and this EMF into I is the power output by the cell. I square R is the power consumed by the internal resistance, or you can say that due to the resistance this much power is consumed. So net power output will be how much? Power given by the cell, that is E into I, minus power consumed by the resistor, that is I square into R. So net power will be EI minus I square R. Clear? This will be I square R. Now take a second case. In second case what I did, same arrangement I am taking here. This is VA, this is your battery, and this is your VB or cell. This is R, this is small r internal resistance. Now here the current is flowing this direction. Now the current is flowing along this direction. I current is flowing along this direction. Can you write down the power? So you will say that power equal to V into I, and V is obviously VA minus VB into I. Clear? Can you find out VA minus VB? So you will say that VA plus E, sorry, VA minus E, here you are moving along this direction, right? This will be your minus E. So VA minus E, and you are moving along this direction, minus IR is equal to your VB. So VA minus VB is equal to E plus IR, right? Internal resistance we have taken, we have taken small r, I into R into I into R. Clear? This is going to happen. So can you put this VA minus VB here? So you will tell that power equal to E plus IR into I, that is your EI plus I square R. This is what? Now the power is consumed by the cell. Why it is power consumed? You observe here. Here the current is flowing from lower potential to higher potential. The battery is behaving like a source, because for a source the current will flow from lower potential to higher potential. Now here the current will flow from the positive terminal to the negative terminal, right, from positive to negative. That means now it is behaving like a load. For a load, the current enters at higher potential and leaves at lower potential. That means here also the cell is behaving like a load, so it will consume the power, it will consume the electrical energy. That means the battery, you can say that the battery is getting charged now, right, because battery you charge na, by electrical energy you charge the battery, then you use that one, right. So here the battery, or you can say the cell, basically cell is behaving like a, here it is behaving like a load. That means in this time this battery or the cell is getting charged, and here it is behaving like a source, right. Two things here. If the current is flowing like this, you can imagine this is behaving like a load. If the current is flowing along this direction, lower potential to higher potential, it is behaving like a source. Clear?